Dear viewers, you are my greatest inspiration. Your kind words of appreciation motivate me to keep making more videos. Mirror is a smooth and highly polished reflecting surface with a silvery metallic coating at the back. Curved mirror is a mirror that has a curved reflecting surface, and is segment of spherical glass surface, instead of a flat surface. Let's say we have this flat reflecting surface here, shown by white line. The normal to the surface is the dashed gray line. As the incident ray bounces off the plane, it follows Snell's law, as we all know very well, which means the angle of incidence is equal to the angle of reflection. Now tell me, what if it was a curved reflecting surface instead of flat? Here you see a curved line shown in blue. A tangent to a curve is a line that touches the curve at one point and has the same slope as the curve at that point. A normal to a curve is a line perpendicular to a tangent to the curve. The laws of reflection at a plane mirror are equally true for spherical mirrors as well. Of course, under certain approximation, as the curved surfaces are locally linear. Look at this curved surface. Let's say its bulging side is the reflecting surface. Now, draw the tangent and the normal, shown by the red dashed lines. Now look at this curved surface. Its inner side is the reflecting surface. Needless to say, curved mirrors are part of hollow spheres. Here we have added the metallic coating on the outer side of sphere A, and inner side of sphere B. The center of the sphere, which the mirror is part of, is called the center of curvature, denoted by C. The geometrical center of the mirror is called its pole, denoted by P. The line joining C and P is called the principal axis. Let's put the light source on the left side of your screen. The reflecting surfaces are of course shown in bright white, easy to recognize. The incident rays are shown in blue. Here you see the reflection with respect to the tangents and normals. It follows the laws of reflection, Snell's law. Convex mirror is a curved mirror, which is a segment of spherical glass surface, and has the bulging side facing toward the direction of the light source, the object. The distance between the pole and the focal point, denoted by f, is called the focal length of the mirror. The geometric ray tracing diagrams show, as the object comes closer and closer to the reflecting side of the mirror, the image formed at the back of the mirror grows in size, but remains virtual, upright and diminished, compared to the object, while remaining inside the focal length. Concave mirror is a curved mirror, which is a segment of spherical glass surface, and has the bulging side away from the direction of the light source, the object. The geometric ray tracing diagrams show, as the object comes closer and closer to the reflecting side of the mirror, the image formed on the same side of the mirror grows in size, moves away from the mirror, but remains real and inverted, until it finally turns into a virtual, upright, and magnified image at the back of the mirror. Please remember to like, subscribe, share,